Hi, I'm Leah Peng with ITCheerup.net. I'm pleased to welcome you to this course, Hands-on with AWS Relational Database Service RDS. In this course, Hands-on with AWS RDS, we will learn how to use AWS RDS for relational database. This course assumes you have no experience on AWS RDS, but are eager to learn AWS solution on relational database. It covers all of the main concepts you need to know about Amazon Relational Database Service. This course has many hands-on laboratories, such as launching AWS RDS DB instance, web application with RDS Database or Aurora serverless in VPC, multi-AZ deployments for failover, monitoring performance, and encryption on RDS. I will cover everything step by step in the videos. You will learn AWS RDS Essentials, Aurora Serverless, RDS Operations, and RDS Maintenance. You will also get the basic knowledge of other associated AWS services, such as S3, IAM, VPC, CloudWatch, and Trust Advisor through those hands-on laboratories. Once you have completed this course, you should be able to deploy your relational database on AWS RDS, operate databases, maintain databases, and set up security on AWS RDS. We will cover the following topics in this course. The first chapter, we will overview AWS Databases options. What is a relational database? What is a non-relational database? What is the purpose of each AWS database option? AWS RDS provides cost-efficient, resizable capacity for an industry-standard relational database and manages common database administration tasks. So in the second chapter, we will overview AWS RDS. What is RDS? We will warm up with two laboratories, create Oracle database and create MS SQL database. Then I will explain the DB instance classes and RDS storage engines. DB instance is the basic building block of AWS RDS. So in the third chapter, we will take a deep look on DB instance life cycle. We will do three laboratories together. Create web application with RDS database in VPC. Simulate RDS multi-AZ for failover. Conduct RDS read replica. We will take a look on the difference between multi-AZ and read replica and how to use them together. Then we recap the DB instance life cycle. In the chapter of Aurora, we will take a look on Amazon's own DB engine, Aurora. We will do the same web application, but with Aurora serverless in VPC. I will explain the Aurora storage engine which is different than the RDS DB storage engine. In the chapter of RDS management tools, we will take a look on RDS auto backup, point-in-time recovery, restore and migrate snapshot, how to use the CloudWatch metrics, CloudWatch alarm, AWS Trust Advisor, tag, events history, logs, and performance insights to monitoring RDS. In the security chapter, we will summarize the security we did in our laboratories and what kind of security should apply and manage on RDS. All my courses offer bonus sections on any new feature released from AWS. The new bonus sections will be added and updated time to time. Well, we have a lot of good information to cover, and I'm so excited to have this learning journey with you. If you are ready, let's get started. You need to have AWS account to practice the laboratories in this course. Please review the attached link on how to sign up and set up free tier account on AWS. We will use SQL clients such as Oracle SQL Developer, MySQL Workbench, and DB Visualizer in this course. You can use any SQL client as long as it supports the DB engine in the laboratories. I will cover the following laboratories step by step in the videos. However, you still may have some questions or need some help. Well, no problem. Just leave the question on Q&A board or drop me a message. I'm a very responsive instructor, and I normally respond within 24 hours. Let's walk through all the laboratories step by step. If you are ready, see you in the next video. In this chapter, AWS Database Overview, we will go through the following topics. What is a relational database? What is a non-relational database? The purpose of AWS databases. And wrap up with a summary of this chapter. What is a relational database? A relational database is a digital database based on relational model of data. A software system used to maintain relational database is a Relational Database Management System, RDBMS. Virtually all relational database systems use SQL, structured query language, for querying and maintaining the database. A relational database is a collection of data items with predefined relationships between them. These items are organized as a set of tables with columns and rows. Let's take a look on the sample custom table. Tables are used to hold information about the objects to be represented in the database. So the custom table represents customs in the database. The rows or the records in the table represent a collection of related values of one object or entity. Each column in the table holds a certain kind of data, and a field stores the actual value of the attributes. Each row in a table could be marked with a unique identifier called a primary key. And rows among multiple tables can be made related using foreign keys. This data can be accessed in many different ways without reorganizing the database tables themselves. In the customer table example, the primary key is the customer ID. The foreign key is order ID. So there will be relationship between custom table and orders table. There could be one-to-one relationship. One custom relate to one order, or one-to-many relationship. One custom record, there's a multiple orders record. What is a non-relational database? Before we talk about the definition, let's take a look on the challenges of a relational database. So relational database assumes a well-defined structure of data and assumes that the data is largely uniform. The relational database leaves the schema of your application and its properties such as columns, types, etc. to be defined upfront before building the application. This does not match well with the agile development approaches for any high dynamic applications. As the data start to grow large, you have to scale your database virtually, adding more capacity to the existing servers. Now let's take a look at non-relational databases to see if that solves the challenge from relational databases. So non-relational database is NoSQL database. NoSQL means not owning SQL. NoSQL database provide a mechanism for storage and retrieval of data that is modeled in means other than the tabular relations used in the relational databases. It is optimized for scalable performance and schema-less data modules. NoSQL database also is widely recognized for its ease of development, low latency, and resilience. NoSQL databases use a variety of data modules, including column, document, graph, and in-memory key value stores. In conclusion, there are three features that differentiate a non-SQL from a relational database: schema-free, free of joins, and supports linear scalability. Let's take a look on AWS options on databases. AWS supports both relational database and a non-relational database. On the relational database, there's a Relational Data Service (RDS) and a Data Warehouse Redshift. RDS is a managed relational database in the cloud that you can launch in minutes with just a few clicks. At the time of this recording, there are 6 database engines on the RDS. They are Aurora, Oracle, MS SQL Server, MySQL, PostgreSQL, and MariaDB. Aurora is the AWS-owned relational database engine. A fully managed MySQL and PostgreSQL compatible relational database with the performance and the availability of enterprise database at 1/10 the cost. Redshift is AWS data warehouse solution. Redshift is a fast, fully managed petabyte-scale data warehouse at 1/10 the cost of traditional solutions. On the non-relational database, AWS provides 3 options: DynamoDB, ElastiCache, and Neptune. DynamoDB is a serverless non-SQL database which delivers consistent single-digit millisecond latency at any scale. It supports both document and key-value data structures. AWS uses ElastiCache to deploy, operate, and scale an in-memory data store based on memcached or Redis in the cloud. Neptune is a fast, reliable, fully managed graphic database to store and manage highly connected datasets. AWS also provides a database migration service, DMS, to help migrating your database to AWS easily and inexpensively with minimal downtime. Let's wrap up what we learned in this chapter. We learned the relational database and a non-relational database. A relational database is a collection of data items with predefined relationships between them. It uses SQL structured query language for querying and maintaining the database. Non-SQL database is a non-relational database with a schema-free data structure. It is optimized for scalable performance. We also talked AWS solutions on relational and non-relational databases. You can use Aurora or RDS for transactional applications like ERP, CRM, and e-commerce to log transactions and store structured data. You can use DynamoDB for internet-scale applications to serve content and store structured and unstructured data. You can use Redshift data warehouse solution on online analytical processing for operational reporting and querying in the big-scale data. For real-time applications like gaming, leaderboards, chat messaging, streaming, and IoT, you can use ElastiCache to store in-memory data. For any application that requires navigation over highly collected data, such as social news feeds, recommendations, and fraud detection, you can use Neptune. In this chapter, we will go through the following topics. What is RDS? We will overview Amazon Relational Database Service. Then we will do 2 laboratories to get familiar with RDS. We will create Oracle Database and MS SQL Database. Run some simple queries on these databases. A DB instance is an isolated database environment running in the cloud. So we will take a look on DB instance classes and storage engines to understand how RDS supports database workloads and computations. Amazon Relational Database Service, AWS RDS, is a fully managed cloud relational database service. It provides cost-efficient and resizable capacity. while managing time-consuming database administration tasks. Free you up to focus on your applications and business. It uses the same pay-as-you-go pricing model with demand, reserved, spot options. RDS takes over many of the difficult or tedious management tasks of relational database, such as backups, software patching, automatically failure detection, and recovery. AWS RDS supports the popular database engines MySQL, MariaDB, Oracle, MS SQL Server, and PostgreSQL. This means that the code, applications, and tools you're already using today with your existing databases should work seamlessly with the Amazon RDS. AWS also provides Data Migration Service (DMS) for you to migrate your on-premise databases into AWS Cloud. RDS can automatically back up your database and keep your database software up to date with the latest version. AWS also has its own database engine, Aurora. Aurora is a fully managed MySQL and PostgreSQL compatible relational database engine. Aurora provides the security, availability, and reliability of the commercial-grade databases at 1/10 the cost. So Aurora is a very powerful relational database engine. AWS recommends everybody using Aurora. We will have one section just focused on Aurora. AWS RDS provides two replication options to enhance database availability, improve data durability, all scaled beyond the capacity constraints of a single database instance for read-heavy database workloads. The multi-AZ deployment gives you the high availability with a primary instance and a synchronous secondary instance that you can fail over to when the problems occur. You can also using the read replicas in MySQL, MariaDB, or PostgreSQL to increase read scaling. We will have one lecture to compare the difference between multi-AZ and read replicas and how to work them together to improve your production environment. In addition to the security, you only have to configure security for your use cases. You don't have to configure security access for processes that RDS manages, such as creating the backups, replicating data between a master and a read replica, or other processes. In your use case, you can help control who can access your RDS databases by using AWS Identity and Access Management (IAM) to define users and permissions. You can also help protect your databases by putting them in our Virtual Private Cloud (VPC). We will have one section to go through all the security options. The basic building block of AWS RDS is the DB instance. In this lab and the next lab, we will create the sample DB instance with the commercial database engines, Oracle and MS SQL. We will set up the DB instance with the public access so you can connect to the DB instance and run a simple query. After you're done the lab, we will delete the sample DB instance. These two labs will help you to understand the DB instance. Then we will have a lab to set up a web application in AWS VPC, Virtual Private Cloud Service. It is a real production example. The web server runs on the VPC public subnet to access the database on the VPC's private subnet. You must have an AWS account before you can create a DB instance. If you don't have any account, please follow the attached YouTube link on how to sign up and set up an AWS free tier account. There is no charge of this laboratory on the free tier account. You also need to have a SQL developer. The download location of the SQL developer will be covered in this video. Let's get started to create the Oracle database on the AWS RDS. After you log in AWS account, go to RDS. And in RDS console, click Create Database button. Select Oracle. Check only Enable options eligible for RDS free usage tier. There are 4 types of Oracle to choose at this video type. For the test, we choose Oracle Standard Edition 2. If this is for production, you should choose Enterprise Edition. Click Next button. The license model is associated with a data engine such as Bring Your Own License. In this example, General Public License you will see in the MySQL example, and license included in the next laboratory MS SQL. In this test, the default license model is Bring Your Own License. On the DB engine version, there are many Oracle versions you can choose, so you can choose the version that works with your current applications. We choose the latest Oracle version for this test. Since we checked only Enable options eligible for RDS free usage tier, you only see one DB instance class, db.t2.macro, with 1 CPU, 1 GB RAM. If you uncheck the free tier option, you can choose different DB instance classes, such as T2 large, M4 large, and R3 large. You can see the CPU and RAM information next to each DB instance class. We will have one lecture on the details of DB instance classes. With the free tier option enabled, the multi-AZ deployment is disabled. You should use multi-AZ for your production environment to support failover and high availability. For this test, we will not use multi-AZ. We will simulate multi-AZ deployment in the next section. The default storage type for free RDS usage tier is General Purpose SSD. The minimum allocated storage is 20 GB. We will use the default storage type and size for this test. We will have a lecture on storage engine. Now enter your DB instance settings. Give DB instance identifier. Specify the master username that you will log on to your DB instance with all database privileges. The master username is a SQL Server authentication login. Enter the password and confirm the password. Click Next button. On the Configure Advanced settings, let's create a new VPC instead of the default VPC for this DB instance. Creating the new VPC gives you the opportunity to use the VPC security. When you select Create a new VPC, it will automatically select Create a new DB subnet group for you. We will click Yes for public accessibility. In our web application lab, we will set a public accessibility to No and show you the real production scenario with only web server access the DB instance. Leave low preference on availability zone so AWS will pick up availability zone for you. We don't have any existing VPC security group, so we create a new VPC security group. Leave the database options as default. You can set up your database name, but I'll leave it as default. For production, you can enable encryption. We will show you this option in the security section. In dev and test environment, encryption is disabled. We will leave backup, monitoring, log experts, and maintenance as default in this lab. We will cover them at the RDS Management Tools section. Click Create Database button. You will see the message Your DB instance is being created. Click View DB instance details to review this DB instance. The DB instance status is creating. I will stop the video until the DB instance is available. The DB instance is ready to connect from SQL client. Go to Oracle to download the SQL Developer. It is free. After you install the SQL Developer in your local, open it. Click New Connection. Give a connection name. Enter the master username and the password that you set up in the DB instance into the username and the password. Now go back to the RDS DB instance to get the endpoint. Copy the endpoint. Paste under the host name. SID is the ORCL or any database name you define in the setup. Click Test to test the connection and click a Connect button. We connected to the Oracle database, and there is a new table in the database right now. Copy the script from attached HR30 SQL. This is the Oracle provided sample HR database. Now click Run the script button. After the script is finished, refresh the tables. Now you can see all the tables created. Same on the views and the procedures. Now let's take a look on the triggers. There are arrows on the triggers. Let's recompile these triggers. The reason is the procedures are created after triggers, so you need to recompile them. I already fixed the issue in the hr-30.sql file, so you don't need to do this step to recompile the triggers. Let's take a quick look on DB instance page. The summary section summarizes the DB engine information. The CloudWatch section has the metrics to monitor the DB instance from the last hour to last 2 weeks. The connection section has the DB connection information. RDS generates the security group for your local to access the DB instance. The details section has all the DB instance configurations and settings. You can also set up a CloudWatch alarms. You can do snapshots. And you can also set up the tags. For example, you can add a tag with the name My Oracle, so you can track this DB instance in the billing system. And you can also view the logs. By the way, we will talk more details in RDS Management Tools lectures. You can do different instant actions such as a stop, reboot, or restore to point in time. You can delete the instance. You can even modify the instance. And on the modify action, you can change such as a multi-AZ deployment, backup options, monitoring options. We will have a lecture on DB Instant Life Cycle to show you how to do all those actions. After we done the test, let's remove this instance by clicking Delete action. Since this is a test, we will not create a final snapshot. Enter the delete me to confirm the deletion. Then click the Delete button. After the DB instance is deleted, let's go to the VPC console. Select the VPC for this DB instance. Click Delete VPC action. Click Yes Please button. This lab is completed. Let's move to the next lecture. The basic building block of AWS RDS is the DB instance. In this lab, we will create the sample DB instance with the commercial database engine MS SQL. We will set up the DB instance with the public access so you can connect to the DB instance and run the simple query. After you're done the lab, we will delete the sample DB instance. After logging to AWS account, go to RDS console. We will create the database on the US East region. You can choose your region based on your location. Click Create Database button. Select Microsoft SQL Server Engine. Check only Enable options eligible for RDS free usage tier. Then click the button Next. For free tier option, it uses Microsoft SQL Server Express Edition. The license model is license included. Same as you saw on the previous lab, you can choose different DB engine version to match with your current applications. We use the latest SQL Server Engine version. Leave the DB instance class and the allocated storage as the default. Under Settings, enter the DB instance identifier, My Instance. Enter the master username and password to log into this DB instance. Confirm the password, then click the Next button. Under the Advanced Settings, check the Create New VPC so we can utilize VPC's security option. Select Yes for the public accessibility. Leave Create New VPC Security Group checked. Leave the database options as the default. Leave the everything as the default. Then click Create a Database button. The DB instance is creating. When the DB instance is available, we can connect SQL client to this DB instance. I use DB Visualizer to connect MS SQL. You can use Microsoft SQL Server Management Studio or any SQL client that supports MS SQL. Open New Connection Wizard. Enter connection name, My MS SQL. Click Next. Select SQL Server JTDS, then click Next. Go back to the DB instance. Under the connection section, copy the endpoint information, paste it into the database server. The database entry is tricky. Your SQL Server DB instance also comes with a database named RDS admin. RDS uses this database to store the objects that it uses to manage your database. The RDS admin database also includes stored procedures that you can run to perform advanced tasks. Enter the DB instance identifier, My Instance. Now enter the master username and the password that we set up on the DB instance. Click the Pin Server button to verify the connection. Then click the Finish button to connect to the database. After we connect to the database, you will see the RDS admin database. And under this database, we can create our test database. First, let's run a query. Let's enter the select at version to check the DB engine version information. The DB engine version information came back successfully, so we can create our test database now. You can copy the SQL from the attached file. Let's run the create database query. Refresh the objects tree. Now you can see the test database. And there's no table. Let's run the second query, create a table. Then do the same thing. Refresh the object tree. And on the table, you can see the persons table. We finished this creating MS SQL lab successfully. Now let's clean up. Run the two job queries to drop table and database. Then go to the DB instance to drop that DB instance. Select My DB instance. Click Delete action. No final snapshot for this test. Click the I acknowledge and enter the delete me to confirm the deletion. After the DB instance is deleted, let's go to the VPC console. Select the VPC for this DB instance. Click Delete VPC action. Click Yes Please button. This lab is completed. Let's move to the next lecture. DB instance is the basic building block of AWS RDS. Our DB instance can contain multiple user-created databases and can be accessed using the same client tools and applications you might use to access a standalone database instance. We saw this during our creating DB instance on Oracle and MS SQL databases. During the creating DB instance process, we saw a drop-down DB instance classes list. You can click the info next to the DB instance class after you selected DB instance class. On the right panel, we'll display the details on this instance class. It will help you to pick up the correct DB instance class. It should be based on the computational, network, and memory capacity required by planned workload of the DB instance. Let's try some examples. For example, let's select the first one, db.t2.macro. You can see 1 vCPU, 1 GB RAM next to the instance class. If you click Info on the right side, you will see the detail on this instance class, such as the type name is micro, instant current generation, CPU information, memory information. There is no EBS optimized, network performance is low, and it is eligible for free tier. Now let's try M4.16x large. In this one, you will see the EBS optimized information is 10K Mbps with 24 Gbps on the network performance. If you select the last one, X1E.32x large, the largest one in this video right now, the EBS optimized information is increased to 14K Mbps. RDS also provides estimated monthly costs on the DB instance, so you can make your decision to pick up the right one that is based on CPU, memory, network performance, and the cost. Let's summarize what we learned on the DB instance classes. There are 3 DB instance classes. The first one is a burstable performance DB instance class type, which is dbt2. You can choose it from micro to large. These instance classes that provide a baseline performance level with the ability to burst to full CPU usage. You should only use these instance classes for development and test servers or other non-production servers. The second DB instance classes type is a standard DB instance class with the db.m3 and db.m4. This instance class provides more computing capacity. The last one is a memory optimized instance classes type with db.r3, db.r4, and db.x1e, which is optimized for memory-intensive applications. Besides DB instance classes, we also need to concern the storage type for DB workloads. Let's move to the next lecture. DB instance on RDS for MySQL, MariaDB, PostgreSQL, Oracle, and Microsoft SQL Server use Amazon Elastic Block Store (EBS) volumes for database and log storage. Depending on the amount of storage requested, RDS automatically stripes across multiple EBS volumes to enhance the performance. We saw the drop-down list on the storage type when we were creating Oracle DB instance. You can click Info next to the storage type. There are 2 storage types: General Purpose SSD, also called JP2. The volumes offer cost-effective storage. It is ideal for a broad range of workloads. These volumes deliver single-digit millisecond latencies and the ability to burst to 3000 IOPS for the extended periods of time. Baseline performance for these volumes is determined by the volume size, so you can set up allocated storage under the general purpose storage type. The second storage type is a provisioned IOPS. Provisioned IOPS is designed to meet the needs of I/O-intensive workloads, particularly database workloads that require low I/O latency and consistent I/O throughput. It provides the flexibility to provision I/O range from 1,000 to 30,000 IOPS. So under the provisioned IOPS storage type, you can enter the allocated storage size and the request number of I/O operations per second. On the estimate monthly costs, you will see two costs, one for the storage and the other one is for the provisioned IOPS. If we change the DB instance class for this Oracle instance to M4.16x large, you will see the additional configuration. Click the additional configuration. You can override the default values by changing the number of CPU cores and the threads per core on the DB instance class. You can click the link Learn More to get more information on this one. RDS DB instance classes support Intel hyper-threading technology, which enables multiple threads to run concurrently on a single Intel Xeon CPU core. Each thread is represented as a virtual CPU, vCPU, on the DB instance. A DB instance has a default number of CPU cores, which varies according to the DB instance type, and this one is only support on Oracle right now. If we choose Microsoft SQL Server Express Edition as DB engine, you will see magnetic storage type. RDS support magnetic storage type is only for backward compatibility. You should not use it for any new storage needs. Let's summarize what we learned so far. AWS RDS, except Aurora, use EBS volumes. There are two storage types. General purpose SSD is for a broad range of workloads. Provisioned IOPS is for I/O-intensive workloads. You can create a MySQL, MariaDB, SQL Server, PostgreSQL, and Oracle RDS DB instance with up to 16 TB of storage. Now let's take a look on Aurora storage type. You can see two capacity types, provisioned and serverless. If you select provisioned, you can choose DB instance class, but there is no storage type. Same on the serverless. So Aurora used a different storage engine. We will talk about the details of Aurora in the later chapter. Right now, just highlight Aurora storage engine. The data is stored in the cluster volume. Utilize the solid-state disk SSD drives. A cluster volume consists of a copy of the data across multiple availability zones in a single region. Aurora cluster volume can grow to maximum size of 64 terabytes. Here is what we learned in this chapter. AWS Relational Database Service (RDS) is a distributed relational database service. It is a web service running in the cloud designed to simplify the setup, operation, and the scaling of a relational database for use in the applications. Complex administration processes like patching the database software, backing up the databases, and enabling the point-in-time recovery are managed automatically. RDS provides you with 6 familiar database engines to choose from, including Amazon Aurora, PostgreSQL, MySQL, MariaDB, Oracle, and Microsoft SQL Server. You can use the AWS Database Migration Service to easily migrate or replace your existing database into RDS. There are 3 AWS RDS DB instance classes: Standard, Memory Optimized, and Burstable Performance. RDS provides 2 storage types: General Purpose SSD, Provisioned IOPS for any new storage. RDS also supports magnetic for backward compatibility. They differ in the performance and price, so you can decide your storage performance and cost to the needs of your database workload. DB instance is the basic building block of AWS RDS. In this chapter, we will take a deep look on DB instance life cycle. We will do 3 laboratories together. Create web application with RDS database in VPC. Simulate RDS multi-AZ for failover. Conduct RDS read replica. We will take a look on the difference between multi-AZ and the read replica, how to use them together. Then we recap the DB instance life cycle. In this lab, we will simulate a production web application with RDS database. We will install Apache Web Server with PHP and create a MySQL database. The web server runs on a EC2 instance using Amazon Linux, and the MySQL database runs on the RDS MySQL DB instance. Both EC2 instance and the RDS DB instance run in a VPC based in Amazon Virtual Private Cloud Service. The VPC has a public subnet for web server and a private subnet for the database. Then we will do a multi-AZ deployments for failover on the database. In the real production, you could put 2 EC2 instances to handle web server failover with AWS Elastic Load Balance. Use Route 53 for web applications DNS name. Here is the step-by-step of this lab. First, create a VPC with private and public subnets. Create additional private subnet. Create 2 VPC security groups for a public web server and a private RDS DB instance. Create a DB subnet group. Create a RDS DB instance. create web server on EC2 instance, set up MySQL database through MySQL Workbench, install web application on EC2 instance, process CRUD operations on web application, modify DB instance with multi-AZ deployment, process CRUD operations on web application after DB failover. In the previous labs, I signed in as a root user to simplify the whole process, but for security practice, you shouldn't do this way in your day-to-day job, especially with a big team. So for this lab, we will log in AWS account with admin user who has a system administrator and RDS full access permission. If you wanted to learn how to set up IAM user, please review it in my YouTube channel. If you are ready, let's log in AWS with admin user. The first thing we need to do is create a VPC with both public and private subnets. Go to VPC dashboard. Click Launch VPC Wizard. Select VPC with public and private subnets. Click Select button. Enter VPC name. My VPC. Select availability zone for public subnet. I select US East 1A. Now select the same AZ for private subnet and give a public subnet name and a private subnet name. And keep in mind we will create another private subnet. You can see the VPC's CIDR block is 10.0.0/16, which has 65,531 IP address available. Then you can see the public subnet CIDR block is inside of the VPC CIDR block. Same on the private subnet. And write down the private subnet. When we create the second private subnet, we need to give a different CIDR block, but need to be inside VPC. If you have a question on CIDR, which is stand for Clusters Inter-Domain Routing, you can take a look on the attached URL to learn more detail on VPC and subnet. We simplify the web application with only one web server, so I've just set up a NAT instance instead of a NAT gateway in the public subnet. The NAT instance allows the private subnet initiate the outbound traffic to the internet. Click Use a NAT instance instead. Select T2.micro as instance type. Click Create VPC button. My VPC is available. Let's check the subnets. Both public and private subnets are available too. So far so good. Now let's move to the second step, create additional private subnet for RDS. Click Create Subnet button. Give a private subnet name, private subnet 2. Select My VPC and select a different AZ. So this time we select US East 1B. The private subnet 1's CRDR is 10.0.1.0/24. So we give a 10.0.2.0/24, which is inside the VPC but different than the subnet 1's CRDR. Then click Create button. The subnet was created. Now you can see all 3 subnets are available in my VPC. Now let's create 2 security groups. One is for public internet access. The other one is for private access, only from web server. Go to Security Groups. Click Create Security Group button. Give the security group's name. This is the public security group. Select My VPC. Click Yes, Create button. Select the security group we just created and go to the Inbound Rules. Click Edit button. And select SH22 so we can telnet the web server to install the web application. The source is your local IP address. Let's add another rule. Let's select HTTP. So this way we have internet access to our web application. So this is from everywhere. So this is 0.0.0/0. Click Save button. Alright, let's create a second security group for the private database access. Click Create Security Group button. Give this a private security group's name. Select My VPC. Click Yes, Create button. Select the private secure gateway we just created. Go to the Inbound Rules. Select MySQL/Aurora on port 3306. Select the public security gateway we just created into the source. This is allowing web server to access database. Next, we need to put 2 private DB subnets into a DB subnet group. Go to RDS console. Click Subnet Groups. Click Create DB Subnet Group button. Enter the name for this subnet group. Give the description. Select My VPC. Click End all the subnets relate to this VPC button. Now remove that public web server. Click Create button. My DB subnet group is ready. Very good. Now go to the instance. Click Create Database button. Select MySQL. And go down, check only Enable options eligible for RDS free usage tier. Click Next button. And keep everything as default here. Since we check the free tier option, so you can see the multi-AZ deployment is no. You can uncheck the free tier option and select multi-tier AZ deployment for our next lab, but I prefer disable now for this test. Then we can modify the DB instance to multi-AZ for our next failover test. Enter the DB settings, enter the DB instance identifier, and give the master username and password to log into the database. Click the Next button. And select My VPC. It will automatically select My subnet group and keep a No for public accessibility. Select Choose the existing VPC security group. Select the Our DB security group and remove the default security group. And give the database name. We use test database name. And keep everything else as default right now. Click Create button. The DB instance is creating. When it is available, let's move to the part 2 of this lab. This is part 2 of our lab web application with RDS Database. In part 1, we created a VPC with one public subnet for web server and two private subnets for RDS Database. We done our DB instance with the MySQL DB engine. Now let's go to the EC2 console to launch EC2 instance for our web server. In EC2 dashboard, click Launch Instance button. Select the Linux AMI that has PHP and MySQL. Select T2.macro free tier eligible for this test. Click Next Configure Instance button. And in here, select My VPC for the network. Select the public subnet. Enable the auto-assigned public IP. Leave everything else as default right now. Move to the bottom. Click Advanced Details. Copy the attached scripts into this text box. This bash script will install the Apache web server with PHP software and MySQL dependency during the EC2 initiation time. Click Next and Storage, and click Next and Tags. And give the tag name My Web Server. Click Next Configure Security Group. Select an existing security group. Select the public security group we created. And click Review and Launch button. And click Launch button. Select Create a new key pair. So we can use this key to SSH web server and set up a web application. Enter key pair name and download the key pair. Click Launch Instance button. The EC2 is running. Copy your EC2's public DNS name. We need to confirm if Apache Web Server is installed and running. Go to your Web Explorer. Type HTTP with your EC2's DNS name. If you see this page, that means everything is installed and is running. Now let's move to the next step. In this step, we will connect to the database from MySQL Workbench through SSH tunnel. Then we will create a table for the web application. In MySQL Workbench, click plus sign to create a new connection. Select standard TCP/IP over SSH as the connection method. Enter the connection name. Copy the EC2 DNS name into the SSH host. You can go back to the EC2 instance, copy, and paste here. Enter the EC2 user as SSH username. Select path to SSH key file. Go back DB instance. Copy the endpoint, then paste into MySQL hostname. Enter the master username you set up in the DB instance into the username. Enter the password you set up in the DB instance and store in the keychain. Click Test Connection button. And the connection is connected successfully. Click OK button. Now open the connection. There shouldn't be any table in the test database right now. You can see the test database on the bottom. And go to the tables, and there's a no table. Copy the create table query in the window and highlight this query. Click Run button. Now let's run select query. Okay, you can now go to select a table, then click refresh all. The new table persons is created with no record. Alright, the database is ready. Now let's telnet into the EC2 instance to make sure everything is ready. First, child mode the SSH key file. The instruction is attached in this video. Then SSH telnet to the EC2 instance with your EC2 DNS name. cd the var www directory. And let's take a look on this directory. All the subdirectories look good. Now download the PHP MySQL package attached to this video. Unzip it in the same directory of your key file. Okay, let's exit the web server. Then we're using sftp command to sftp the web application package into the web server. You can copy each sftp command from the attached instruction in here. I put the video in the faster mode on the SFTP commands. After you done the SFTP, please run ls space -l to confirm everything is copied. Then quit the SFTP. We need to telnet web server again. Go to db-inf.inc directory, nano db-inf.inc file to modify with db instance endpoint, master username, and password. After you've done the modification, enter Ctrl X to save the changes. The web application is ready to run. Go to the Web Explorer. Enter the URL with your EC2 DNS name /index.php. We can do CRUD operations on this web application, such as end some contracts, then display the contract list, update the contract. We can also delete the contract. So after we've done the actions, we can run select query against the database to verify the changes is in the database. If you are ready, we will use this web application for our next lab. We will modify DB instance to enable multi-AZ deployment. So we can simulate a multi-AZ deployment and test the web application after the failover. Let's get started. AWS RDS multi-AZ deployments provide enhanced availability and durability for database instances, making them a natural fit for production database workloads. When you provision a multi-AZ DB instance, RDS automatically creates a primary DB instance and synchronously replicates the data to a standby instance in a different availability zone. In this lab, we will modify DB instance to support multi-AZ deployment and simulate failover on DB from one AZ to another AZ. We will use the same DB instance from our previous experiment. Let's take a look on my DB instance details. Write down this DB's endpoint. You can see the current availability zone is US East 1B. Multi-AZ is set to no right now. Click Modify button. Select Multi-AZ to Yes. Click Continue button. And select Scheduling of modifications to apply immediately. Click Modify DB Instance button. The DB instance status is modifying. Let's go back to the instance. When the status changes to available, let's double check on my DB instance. Now you can see the availability zone still 1B, but the multi-AZ is changed to yes. What we need to do is reboot. Now select Reboot from Instance Actions. Check the Reboot with failover. Click the Reboot button. The DB instance status is rebooting. When the DB instance is available, click My DB instance. You can see the endpoint is the same. The availability zone changed from US East 1B to US East 1A. Since there is no change to DB instance endpoint, the web application and SQL client should work as before. Refresh the web application. It is displaying the same results. Let's go to MySQL Workbench. Run the select query. It is return the same result. So data is replicated. Good job, we finished the test successfully. Let's clean up the environment to avoid any charge. Click Delete button to delete my DB instance. Select No for final snapshot. Check the I acknowledge box. Enter Delete Me to confirm deletion. Click the Delete button. Now let's go to the EC2 instance. We need to terminate two EC2 instances. One is for the web server, the other one is for net instance. Go to the Actions, then select Terminate. Click Yes, Terminate button. Now we also need a release associated elastic IP to avoid a charge. So go to the Actions, click Release Address. Click the Release button. Now let's go to the VPC. Go to the VPCs. You have two VPC here. One is the default one. The other one is My VPC. Select My VPC. Then go to the Actions list. Select Delete VPC. But you cannot delete the VPC right now. The reason is because DB instance is still deleting. After DB instance is deleted, now you can go back to VPC. Go to the VPCs list, select My VPC. Go to the Action, select Delete VPC. Click Yes, Delete button. Let's go back to the EC2, confirm if the two instance is terminated right now. Let's double check on the elastic IPs, and there's no IP address. The only thing left is key pairs. Please keep this key pair for our next lecture. Let's summarize what we learned in the failover simulation. In the case of an infrastructure failure, RDS performs an automatically failover to the standby, so that you can resume database operations as soon as the failover is completed. Since the endpoint for your DB instance remains the same after failover, your application or SQL client can resume database operations without the need for manual administrative intervention. Multi-AZ deployments for Oracle, PostgreSQL, MySQL, and MariaDB DB instance use Amazon's failover technology. SQL Server DB instance use SQL Server mirroring. Aurora replicates works differently. We will talk about Aurora replicates in the chapter of Aurora. Now, if you are ready, let's move to the next video of read replica. RDS read replicas provide enhanced performance and durability for database instances. This feature makes it easy to elastically scan out beyond the capacity constraints of a single DB instance for read-heavy database workloads. You can create one or more replicas of a given source DB instance in the same availability zone, cross-AZ, or cross-region. In this laboratory, we will create a read replica from SourceDB instance. Then we will test it on SQL client after the read replica is available. First, I will create a DB instance with MySQL engine. This DB instance will be our SourceDB instance. The DB instance will have a publicly accessible, so we can collect a DB instance from MySQL Workbench. On RDS console, click Create Database button. Select MySQL engine. Check Free Usage tier option. Click Next button. Leave everything as the default. Enter the DB instance identifier, my instance. Enter the master username and the master password. Click Next button. Leave everything as default. Change the public accessibility from No to Yes. Give a database name, test. Click Create a Database button. When the database is ready, let's double-check on my instance. Copy the endpoint. We will use this endpoint to connect from SQL Workbench and make sure the public accessible is yes. Now open the MySQL Workbench. I already have MySQL connection set up. You need to make sure the connection method is a standard TCP/IP and paste the endpoint into the host name. Enter your master username and password you set up in the DB instance. Then open the connection. Copy the attached queries and paste here so we can set up a table and records. Let's run the create table query first. After this query done, let's refresh the table. And you can see the persons table is created. Then we run all the insert records queries. Now after that done, we run the select query. And you can see we have 4 records in the table right now. Let's go back to the DB instance. Under the instance actions, click Create Read Replica. You can choose destination region different than your source region if you want to create a cross-region replica. You can choose any region on that drop-down list. We will leave it as default in the same region. Leave DB subnet group as the default. Leave AZ as no preferences, so AWS will pick up AZ for us. Change it publicly accessible from a no to yes. Keep everything else as default. In here, I need to point out, under the instance specifications, you should keep the replica instance specification as same as the source DB instance. That means the same DB instance class and the same storage type. Now give this DB instance a name. Let's call the my instance read replica. Click Create Read Replica button. Now let's check on the status of each instance. Click Instances. You will see source instance status is modifying. Read replica instance is creating. You may wonder how AWS does read replica. Go to the snapshots. There's already a snapshot when we created the source DB instance. Then AWS will make another snapshot on the source instance, which includes the DB change we just did. AWS will use this new snapshot to build the read replica instance. You can see both instances is available right now. Click Read Replica Instance. Let's take a look on the detail on the instance. You can see the endpoint is different than the source instance endpoint. It is easy to understand because AWS generated two individual instances. Copy the endpoint. Open the MySQL workbench. Let's set up another MySQL connection for this read replica instance. Follow the same connection instruction. Give the connection name. Paste the read replica instance endpoint into the hostname. The read replica instance uses the same DB username and password as your source instance. Click a Test Connection button. It made the connection successfully. Let's open this read replica connection. Click Open Connection. Now, let's run select query. You can see the read replica has the table and the same records in the table. Let's try to insert a record on this read replica instance. It's failed because read replica DB instance can only do read operation and cannot modify the database. From the events list, you can understand what happened on the read replica. Click Events. You can see there are three events related to the read replica. First, AWS made source DB instance backup, then restored it from snapshot to the read replica instance. Last, AWS did replication for the read replica. There are some behaviors on the read replica I would like to share with you. First, if you go to the source DB instance, on the instant actions, you can do create read replica or create Aurora read replica. Aurora is cheaper and faster than the other DB engines in RDS. If you do Aurora read replica, there will be no region to select. You will have a multi-AZ deployment option. Because Aurora uses a different replication, we will talk this in the chapter of Aurora. The promote read replica is disabled. It is easy to understand since this is the source DB instance. You can take a snapshot and restore to point in time on the source DB instance. Let's take a look on the read replica DB instance and see what kind of actions you can do on the read replica DB instance. Since this is a read replica DB instance, so you cannot do stop, you cannot create another read replica, and you cannot restore in point in time. But you can promote a read replica to be a standalone DB instance. Since you can promote a read replica, so you can take a snapshot, then use the snapshot. Now let's stop source DB instance and see what will happen. Click Yes Stop Now button. You got an error message. So you can't stop source DB instance if the read replica DB instance is still running. Now let's go back, select read replica DB instance. And you can see you cannot stop on read replica DB instance. You can reboot or delete it. Let's delete the source DB instance and see what will happen. Check the acknowledge. Enter the delete me to confirm a deletion. Click the delete button. And you can see the source DB instance is deleting. The read replica instance is modifying. Let's take a look on the events. The source DB instance is shut down. Now go back. You can see the read replica instance is available. Let's take another look under the events. From here, you can see the whole procedure. First, AWS shut down the source DB instance, then promoted the read replica instance to a standalone instance. Then read replica is shut down. Then read replica is started. After that, source DB instance is deleted. Now let's take a look at what action right now under the read replica instance. Even this is a standalone instance right now, but you still cannot do a restore to the point in time, create a read replica, promote a read replica. If you see something different, please feel free to share with me. This is how I see during the video of this time. Let's remove the read replica instance. Click delete button. Let's go back to the events again. And you can see the read replica is deleted. Let's summarize what we learned on read replicas. Read replicas serve a high-volume application read traffic from multiple copies of your data, thereby increasing aggregate read throughput. Read replicas can also be promoted when needed to become a standalone DB instances. Read replicas are available in RDS for MySQL, MariaDB, and PostgreSQL as well as Aurora. Let's take a look on multi-AZ deployments and read replicas and how we use both replication options in RDS. RDS multi-AZ deployments and read replicas are complement to each other. Both features maintain a second copy of your data. Multi-AZ deployments focus on high availability and failover with synchronized replication. Read replicas focus on read scalability and performance with asynchronous replication. When you use multi-AZ deployments, only database engine on primary instance is active. But with the read replicas, all read replicas are accessible and can be used for read scaling. Multi-AZ deployments only span 2 availability zones within a single region, while read replicas can be within the same availability zone, cross-AZ, or cross-region. Automatic backups are taken from a standby on multi-AZ deployments, but there's no backups configured by default in read replicas. Multi-AZ deployments are in 1 DB instance, so database engine version upgrades happen on primary. Read replicas are in separate DB instances, so database engine version upgrade is independent from source instance. Multi-AZ automatically fail over to standby when a problem is detected. Read replicas can be manually promoted to a standalone instance. In conclusion, you can combine multi-AZ deployments and read replicas to enjoy the benefits of each. For example, you can configure a source database as a multi-AZ for high availability and create a read replica in a single AZ for read scalability. In this lecture, we will talk about DB instance lifecycle. The basic building block of RDS is the DB instance. In our previous labs, we created a DB instance with a DB engine. After you create DB instance, you can use any standard SQL client application such as MySQL Workbench, DB Visualize to connect to the DB instance. Most modifications to a DB instance can be applied immediately or deferred until the next maintenance window. Some modifications, such as a parameter group, require that you manually reboot your DB instance for the change to take effect. We did reboot in our multi-AZ failover simulation. You can see the maintenance details on DB instance page. Maintenance most often involves updates to the DB instance underlying operating system or database engine's version. You can modify maintenance window such as start date time and duration. You can rename your DB instance, but I don't recommend to do that. Let me show you why. After you click a Modify button, in the modification page, go to DB Instance Identify. You can enter the new DB name. For example, let's change from my instance to my instance new. You can also change the master password. Click a Continue button. You can see when you change a DB instance identifier, the endpoint will be changed too. So you need to manage this updated DB connection information. You can apply the change immediately or next maintenance window. You can also stop DB instance for up to 7 days. If you do not manually start your DB instance after 7 days, it will be automatically started. If you just want to use RDS for any temporary purpose, you can delete the instance with a final snapshot. Then go to the snapshots, select the snapshot you want to restore. Then select a Restore Snapshot from Actions list. To start the stopped DB instance manually, you can click Start on the instance actions. You can also delete the DB instance by select Delete from Instance Actions. We did delete DB instance in our previous labs. Here is the summary of DB instance life cycle from creating DB instance to deleting DB instance. If you are ready, let's move to the next lecture. In this chapter of Aurora, we will take a look on Amazon's own DB engine, Aurora. We will do the same web application lab, but with Aurora serverless in VPC. I will explain the Aurora storage engine, which is different from RDS DB storage engine. What is Aurora? Aurora is a fully managed relational database service developed and offered by Amazon. As the same as other DB engines in RDS, that Amazon takes care of time-consuming administration tasks like hardware provision, database setup, patching, and backups. It is a MySQL and PostgreSQL compatible relational database, beautiful in the cloud. Amazon claims that Aurora is up to 5 times faster than standard MySQL database and 3 times faster than standard PostgreSQL database. It provides the security, availability, and reliability of commercial-grade databases at 1/10 the cost. Aurora features a distributed fault-tolerant self-healing storage system that auto-scales up to 64 TB per database instance. Aurora delivers high performance and availability with up to 15 low-latency read replicas, point-in-time recovery, continued backup to S3, and replication across 3 available zones. In this lecture, we will launch the same contact utility web application that we used in our DB instance lifecycle web application lab. The step-by-step instructions are very similar to each other. We will create a VPC with private and public subnets. Create additional private subnet. Create 2 VPC security groups, one for web server public access and the other one for database private access. Create a DB subnet group. Instead of creating DB instance, we create Aurora cluster with Aurora serverless option. Create web server on EC2 instance. Set up Aurora MySQL Database through MySQL Workbench. Install web application on EC2 instance. Then process the CRUD operations on web application. After we done the CRUD options, we will clean up Aurora cluster and VPC. Because the steps are similar to the previous lab, I will put some steps on faster mode. If you need to learn the details of those steps, please go back to DB Instance Lifecycle chapter. Aurora Serverless is not free on free tier account, but the charge for this lab is very minimum, less than $1. Make sure you are okay with the charge from AWS before you do the test. Go to VPC. Click VPC with public and private subnets. Enter VPC's name, public and private subnet names. Select same availability zone for public and private subnet. Select a NAT instance, then click Create VPC button. After the VPC is created, click Subnets. Create another private subnet by entering subnet name. Select My VPC. Select a different availability zone and enter the different IP CIDI blocks. Click Security Groups. Create two security groups. The public access security group MyVPCSG is for web server. Edit its inboard rules by ending HTTP with port 80 for source from everywhere 0.0.0/0 and SSH with port 22 from your local IP. The private access security group MyVPC-DBSG is for database. Edit its inbound rules by ending MySQL/Aurora with port 3306 from the public access security group MyVPCSG. Go to RDS. Click Subnet Groups. Enter group name. Select VPC MyVPC we just created. Click End all the subnets related to this VPC. Remove public subnet. On RDS console, select Clusters. Click Create Database button. Select Amazon Aurora. Select MySQL 5.6 compatible for Aurora serverless capacity. Click the Next button. Select a serverless option. Enter DB cluster settings. Enter the DB identifier, master username, and password. Click the Next button. Under the advanced settings, we can utilize additional scaling configuration. We choose Aurora serverless, so the database will automatically start up, shut down, and scale up or down capacity based on the application's needs. Aurora Serverless enables you to run your database in the cloud without managing any database instances. We can change the maximum Aurora capacity units Let's choose 8, which is the 16 GB RAM for this test. Select My VPC. Choose Existing VPC Security Groups. Select the Private Access Security Group My VPC DBSG and remove the default one. Under the additional configurations, keep everything as default. The only thing I want to point out here is on the backup. You can see the backup retention period is 1 day. Also, the encryption has the master key, the default master key, AWS/RDS. If you click the link next to backup relation period, you can see Aurora offers 1 day backup retention for free, which is good. And you also can see the encryption with the master key. This is the default one. Click the Create Database button. Let's go to the EC2 console. Click Launch Instance button. Select Linux AMI with PHP and MySQL. Select T2 micro instance type for free. Configure instance details by selecting My VPC, selecting Public Subnet, enabling the auto-assigned public IP. Under the Advanced Details, copy and paste installation subscripts. Select Public Web Access Security Group, My VPC SG. I will use the existing key pair. If you don't have, you can choose new key pair. After you done the EC2 instance, you can confirm the installation by opening Web Explorer, then entering the http://ec2's instance IP address. If you see this page, that means you got EC2 installed. Let's set up a new connection on MySQL Workbench. Enter the connection name, select a standard TCP IP over SSH connection method. Enter the EC2's DNS name in the SSH hostname. Enter the EC2 user into the SSH username. Put the key pair file in the SSH key file. Copy and paste the database endpoint into the MySQL hostname. Enter the master username and password you set up on the Aurora serverless cluster. Click the Test Connection button. The connection is successfully made. Now let's open the connection. We will use the same query scripts that we used in the previous DB Instance Cycle lab to create a test database and a persons table. Let's SFTP the web application package into the EC2 web server. Use the same SFTP commands. The commands are attached to this video. Then telnet to EC2 instance web server. Go to dbinf.inc file. Modify the file with the Aurora serverless cluster's DB connection information. Open the web application, and in here, you can do the same Add new contacts, edit the contact, or delete the contact. After you've done the operations, go to the MySQL workbench, enter the select query to verify the table changes after web operations. To avoid any further charge, you should remove Aurora cluster and VPC after you've done the test. Go to the Aurora cluster, click Delete Cluster under the Actions. You cannot remove VPC before you terminate the EC2 instances. Go to the EC2. First, disassociate elastic IPs, then release the EIP. Then you can terminate two running EC2 instances. Now go back to the VPC. Delete the VPC. You can keep a keep here for any further test. Congratulations on finishing this web application with Aurora Serverless Database. If you are ready, let's move to the next lecture on Aurora Storage Engine. In the web application with Aurora Serverless Database Lab, we didn't need to select any DB instance type or set up allocated storage size, because Aurora uses different storage engine than other DB engines in RDS. In RDS console, you will see instance and clusters. Aurora DB cluster consists of one or more DB instances and a cluster volume that manages the data for those DB instances. Aurora data is stored in the cluster volume, which is a single virtual volume that utilizes solid-state disk drivers. A cluster volume consists of copies of the data across multiple availability zones in a single region. Let's take a look on Aurora DB cluster diagram. From this diagram, you can see Aurora automatically replicates your storage 6 ways across 3 availability zones. Because the data is automatically replicated across availability zones, your data is highly durable with less possibility of data loss. This replication also ensures that your database is more available during a failover because the data copies already exist in the other availability zones and continue to serve data requests to the DB instance in your DB cluster. So Aurora storage is fault-tolerant and self-healing. Aurora cluster volumes automatically grow as the amount of data in your database increases. Aurora cluster volume can grow to a maximum size of 64 terabytes. Table size is limited to the size of the cluster volume. That is, the maximum table size for a table in Aurora DB cluster is 64 TB. Even though an Aurora cluster volume can grow up to 64 terabytes, you are only charged for the space that you are using in the Aurora cluster volume. Because Aurora automatically performs continuous backups, Aurora cluster does not require extensive planning or downtime for performing backups. In this chapter, RDS Management Tools, we will take a look on RDS backup and restore, such as auto backup, point-in-time recovery, restore and migrate a snapshot. We will also take a look on the monitoring tools, such as CloudWatch Metrics, CloudWatch Alarm, AWS Trusted Advisor, Tag, Events History, Logs, and Performance Insights. AWS RDS creates and saves automated backups of your DB instance. RDS creates a storage volume snapshot of your DB instance, backing up the entire DB instance and not just the individual database. RDS saves the automated backups of your DB instance according to the backup retention period that you specify. If necessary, you can recover your database to any point in time during the backup retention period. You can disable backup by setting backup retention period equals 0. You can also manually take a snapshot, then restore, copy, or share the snapshot. Copying the snapshot to another AWS account is a two-step process. You first create a manual snapshot from the automated snapshot, and then you copy the manual snapshot to the other account. You can restore a DB instance to a specified point in time, creating a new DB instance. When you restore a DB instance to a point in time, the default DB security group is applied to the new DB instance. You can also modify the security group. Let's take a look in the following laboratory. On the DB instance page, you can see all snapshots under the Snapshots section. You can click Take Snapshot button, or go to the top under the Instance Actions, then click Take Snapshot to manually take a snapshot. Let's take a look on Backup Retention Period. Click Modify button. Go to Backup section. You can change backup retention period from 0 day, which is disabled backup, to 35 days. You can modify start time and duration. Let's change the retention day to 10 days, start time to midnight, and keep the duration no change. Click Continue button. And in here, you can schedule this modification right away or the next maintenance window. Click Modify DB Instance. Now click Take Snapshot. Enter the snapshot name, Test, Snap. Click Take Snapshot button. Go to the snapshots and you can see the new snapshot is creating. Then it is available. Now go back to my instance. Let's do restore to point in time. You can choose point in time to restore from a latest restorable time or specify a custom date and time to restore from. Keep everything else as default. Enter the DB instance identifier. Let's call it my instance PIT test. Click Launch DB instance, and you can see the new DB instance is creating. The new instance is available. Let's take a look on the events history. We can see the step-by-step how AWS RDS backup, then restore, then create a new instance. You can see the menu snapshot is created, then new instance is restored from my instance. You can also see the snapshots related to this process. Let's take a look on the new instance. On the new instance page, you can see all the details, such as its own endpoint, details, events, snapshots, logs. If you click a Modify button, you can also choose a different security group for this new instance. Let's delete this instance before we move to the next test. This time, let's do Migrate Snapshot. Click Migrate Snapshot under the instance actions. You can see the DB engine is Aurora MySQL. You can select a DB instance class. You don't need to change the DB engine's version. Enter the DB instance identifier and keep everything else as default right now. Click a Migrate button. You can see our previous instance is deleting and this new migrated instance is creating. Since Aurora MySQL DB engine is under the cluster, let's take a look on the cluster page. You can see the detail of this cluster and a new migrated DB instance as its member. You can see the new instance is available. Also, the cluster is available. Let's take a look on the events history. From here, you can see step-by-step on migrating DB instance from the snapshot. You can also see the related snapshots for this migration process. Let's take a look on this migrated DB instance. The migrated DB instance has the same sections in the page, but there is a new section called Cluster for this DB instance. You can see the detail of this cluster. The cluster has the same backup retention period as the original DB instance. Let's take a look on the cluster page. The cluster type is provisioned, which is different than what we did in the web application with Aurora Serverless cluster. The migrated DB instance rule is right in the Aurora cluster. Now you cannot connect to this migrated DB instance or cluster through MySQL Workbench due to the security group. Click the Modify button. Let's change the security group by switching to MyDB instance security group. This is the easy way, or you can create a new security group for this DB instance. Select Apply immediately. Now you can see the security group do have your local IP address. Copy either this DB instance endpoint or the cluster's endpoint. Now go to the MySQL Workbench. Copy the endpoint into the host name. Test the connection. Now let's open the connection. After you open the connection, you can run the query like before. Let's do a select query. And you can see the same result from a DB instance. Congratulations on finishing this test. Let's do cleanup. Select the cluster. The delete cluster is disabled because the DB instance is still running. Let's delete the DB instance first. Go to the instance, select the migrated DB instance, select Delete, click Delete button. Now the migrated DB instance is deleted. Since the cluster only has one DB instance, the cluster is removed too. If you are ready, let's move to the next lecture. In this lecture, let's take a look at monitoring options on AWS RDS. The first monitoring tool we can use is CloudWatch. Instead, go to CloudWatch console. You can review the metrics on the CloudWatch section on DB instance page, such as CPU utilization, write-read IOPS, network retrieve throughput. If you have multiple DB instances, click Add Instance to Compare button to compare DB instances' performance. Right now, under the monitoring, only CloudWatch is enabled. I will show you how to enable the other two options. You can also select the period of time to review on the CloudWatch, such as last minute, last hour, or last 2 weeks. To enable two options on the monitoring, let's modify DB instance. On the monitoring section, click Enable Enhanced Monitoring. You can also select which log type you want to publish to the CloudWatch logs. Click Continue. Select Apply immediately. Click Modify DB Instance button. After you refresh the DB instance page, now you can see all three options on the monitoring. Click Enhance the Monitoring. You can see the details such as the free memory, active memory, and the CPU user. You can also click OS Process List to review processes detail. On the DB instance page, you can review logs under the Logs section. Select the log. Then you can view, watch, or download it. You can also click the log itself to review it. You can review the recent events. On the left panel, you can click Subnet Groups to review the details. You can select a subnet group, then review its details. You can review on the parameter groups. You can modify a parameter by selecting Parameter Group, then search the parameter. Click the Edit Parameters button. After you've done the change, you can save the changes. You can also review the option groups. You can select the option, then click the option to review the details. To review the event's history, under the events, you will see the detail of each event. You can also create an event subscription by click Create Event Subscription button. Enter the subscription's name. Select the target from ARN, email, or SMS topic for AWS SNS notification. Based on the topic type, to fill the required fields such as topic name, recipients. Choosing the source type of resource. For example, let's choose instances. You can specify the instances. You can also specify the event categories, such as backup, failover. Let's select failover. Let's try another example. If we select source type snapshots, you can do all, or you can select a specific snapshot. You can also select a category such as notification, deletion. From AWS Trust Advice dashboard, you can review the cost optimization, security, fault tolerant, and performance improvement checks, such as RDS public snapshots, RDS cluster roles, RDS subnets per subnet group, RDS option groups, RDS event subscribes, RDS total storage quotas, RDS DB instance. On DB instance page, you can add tag to track the cost. For example, we put a name, then we put an instance name with DV, so when we see the cost, we know this is from a dev system. You can also create CloudWatch alarm. You can set up a new notification with either email or SMS topic for AWS to send a SNS notification. You can select the metric you wanted to track You can set up the thresholds, then create alarm. The last monitoring tool is Performance Insights. Our DB instance didn't have any heavy load, so I cannot simulate performance insights. Please review the attached video on using performance insights to analyze and troubleshoot your database performance. Performance insights support on MySQL, Aurora, and PostgreSQL. Let's summarize what we learned on the RDS monitoring. We can use CloudWatch metrics and alarm to monitor RDS traffic and usage. We can review logs and events to understand what happened in RDS. We can use a tag to track the cost. We can use AWS Trust Advisor to review the cost optimization, security, fault tolerance, and performance improve checks. We can use the performance insights to analyze and troubleshoot your database performance. If you are ready, let's move to the next lecture. We saw in our web application with RDS libraries that we created a DB instance or Aurora serverless cluster in VPC. Run your DB instance in VPC so you can utilize VPC for the network access control. We can use AWS identity and access management policies to assign permissions that determine who is allowed to manage RDS resources. For example, we log in with IAM user that has RDS full access permission on web application with MySQL Database library. You can even set up IAM policies to allow such as create, describe, modify, and delete DB instances, tag resources, or modify security groups. We set up 2 security groups in our web application lab to control what IP address or EC2 instance can connect to your database on a DB instance. We can use the secure socket layer SSL connections with DB instances running in the MySQL, MariaDB, PostgreSQL, Oracle, or Microsoft SQL Server database engines. Each DB engine has its own process for implementing SSL. We can use RDS encryption to secure your RDS instances and snapshots at rest. RDS encryption uses the industry standard AES 256 encryption algorithm to encrypt your data on the server that hosts your RDS instance. If you're using Oracle DB engine, you should use the network encryption and transparent data encryption with Oracle DB instances. We can use the security features of your DB engine to control who can log into the databases on a DB instance. For example, grant privileges on the database just as you do if the database was on your local network. In this lecture, we will take a look on RDS encryption at rest. We also will take a look on authentication options. If you choose MySQL or Aurora MySQL engine for the DB instance, you will see IAM DB authentication option. With this authentication method, you don't need to use a password when you connect to a DB instance. Instead, you're using the authentication token. An authentication token is a unique string of characters that RDS generates on request. Authentication tokens are generated using AWS Signature version 4. Each token has a lifetime of 15 minutes. You don't need to store users' credentials in the database because authentication is managed externally using IAM. You can also still using the standard database authentication. If you choose Oracle, MySQL, Aurora, MariaDB, PostgreSQL DB engine for the DB instance, you will see the encryption section. RDS encrypted DB instances provide an additional layer of data protection by securing your data from unauthorized access to the underlying storage. You can use RDS encryption to increase data protection of your applications deployed in the cloud and to fulfill compliance requirements for data at rest encryption. To manage the keys used for the encryption and decryption your RDS resource, you use the AWS Key Management Service KMS. AWS KMS combines secure, highly available hardware and software to provide a key management system scaled for the cloud. Using AWS KMS, you can create encryption keys and define the policies that control how these keys can be used. AWS KMS supports CloudTrail, so you can audit key usage to verify that keys are being used appropriately. In this DB instance, we didn't enable IAM DB authentication and the RDS encryption. Click the Modify button. Now in here, you can enable the IAM DB authentication, but there's no encryption section for you to modify. So you can only enable RDS encryption during DB instance creating time. If you choose Microsoft SQL Server DB engine for the DB instance, you can work with AWS Directory Service for Microsoft Active Directory, also called AWS Managed Microsoft AD, to enable Windows authentication. When users authentication with a SQL Server DB instance joined to the trusted domain, authentication requests are forwarded to the domain directory that you created with AWS Directory Service. By the way, Microsoft SQL Server DB engine doesn't support RDS encryption. Let's summarize what we learned in this lecture. RDS encryption at rest is automatically integrated with AWS KMS at a DB instance level. It is enabled during DB instance creating time. You can utilize the IAM database authentication on MySQL DB engine. You can also utilize Microsoft AD authentication on Microsoft SQL Server DB engine. If you are ready, let's move to the next lecture. Congratulations on finishing the course hands-on with AWS RDS. Let's recap what we learned in this course. We compared the difference between relational database and a non-relational database. We overview the purpose of AWS databases. We learned AWS RDS core concepts such as DB instance classes, storage engines, DB instance lifecycle, Aurora, AWS RDS multi-AZ deployments, and AWS read replicas. We set up a web application with MySQL Database or Aurora Serverless Database step by step on AWS RDS inside VPC. We simulated multi-AZ failover and read replica on AWS RDS. We used point-in-time recovery and snapshot migration to create a new DB instance from the original DB instance. We demonstrated AWS RDS management tools to monitoring database performance, such as on CloudWatch, Events History, Logs, Trust Advisor, and Performance Insights. We reviewed AWS RDS security and practiced RDS encryption and authentication. If there is any new feature released from AWS, I will make bonus sections on these new features. If you feel anything still unclear or missing, please feel free to leave the questions on Q&A board or drop me a message. If you liked this course, please take a moment to share your experience by rating it and share your feedback by leaving a review or comment. If you want to learn more on other AWS databases, please enroll my course on AWS Data Warehouse, which is focused on Redshift, QuickSight, and machine learning. If you want to learn more on non-SQL database, please find my course Hands-on with AWS DynamoDB, which is focused on non-SQL database on cloud service, such as serverless web application, DynamoDB streams with TTL, and global tables replications. Again, it was a pleasure to have you in this course. See you next time.